I'm here at MacStadium in Las Vegas, Nevada, here with Paul Bonatti. Paul, you are the COO of MacStadium.
That's correct.
So I have a question for you.
Yeah.
Why is it that someone would need a Mac in a data center?
They don't want to mess with the hardware themselves. They're developers, for example, and they just want someone to take care of the hardware. But there's also various services and products we provide, AI inference work, VDI, and virtualization.
So that's the why. Let's look at the how, because Macs aren't really designed to be in a data center environment.
That's right, they're consumer devices. This is the first example from our history, and it's still in use today. We affectionately call these library racks, and you can get 460 Mac Minis in each one of these.
So the library racks were generation 1.
That's right.
Let's look at generation 2.
Absolutely. So this is our generation 3 capability for racking. The second generation was nothing more than a drawer to pull out, and we would put 4 minis on that. Unfortunately, with that design, thermal became a real problem, especially with the 2018 Mac Mini, which the Intel chipset was known to be quite hot, right? And so we actually had a moment in time where in our Atlanta data center, when we first came out with that design, where we actually had to go and go down to the local hardware store and buy some box fans to cool them off, because the CPU cycle consumption was at 100% based off what this customer is doing. And so we had to flow the cold air across it actively. But we knew because of that, we needed to come up with a different design. This is what we affectionately call the toaster. It's because of the way these are slotted in here. These are 2018 minis, so they're as the same heat problem, right? But we have a cold aisle and a hot aisle. So what happens is the cold from this cold contained aisle comes down this shaft, and the fan of the mini actually blows it across it and then pushes it down the heat aisle.
So you don't have an active fan in here?
We do not. We can actually mount an active fan here if we needed to, but even with the 2018 mini, this design is superior on thermals.
And at this scale, the more you can delete, the better. Because when you talk about physical components, mechanical components, they're going to fail. It's not a question of if, but what the tolerances are. And so at this scale, if you can reduce a component, you're reducing a failure component, you're reducing the amount of tickets for a technician to have to come out and replace that component.
100%. And our mantra is keep it simple, right? The less complex this is, the easier it is for us to manage and control. And that's the name of the game.
And the more reliable it is for your customers.
100%. So generation 4 is a totally different design that MacStadium controls the IP.
Okay.
Right? So with the first generation of the library rack and the third generation, we worked with 2 different firms to actually take our thoughts and design it. And as you can tell, it's designed in metal, right? Metal is fine, but it's heavy and it's costly.
Yeah.
And it takes a long time to develop what you're going to end up with, all right? Yeah. So if we fast forward, about a year and a half ago, we bought some 3D printers. The reason we bought the 3D printers is it allows us to rapidly develop our ideas. What you're seeing here is our end result. This is version 1 of our 4th generation racking. We have slots here that the Apple Pi unit fits into, so there's no movement. We have the shroud for the heat, so the fan blows the cold air through it, and then pushes it up into the heat shroud and out the back, right? In the front, although we don't have it here, we actually have a grill that we can put here, and we can actually actively throw air across it with 2 fans. The benefit of this design is more than just the rapid development of how we can go from a brand new design like the M4 supposedly will be. Key element to this was the KVM system. This KVM system allows us to control the individual mini in every aspect except for physically grabbing it and moving it.
So short of this thing catching on fire, it's complete lights out data center.
That's right.
Can we take one of these out and go look at it?
Yes, we certainly can.
So we got a Pi.
Yep, so we got a Raspberry Pi, right, and obviously the Apple Mac in there. And so collectively, we call this the Apple Pi system, and then it fits into the racks as we've shown on the other video. We've 3D printed originally for the R&D part, but injection molded the stand that this fits into.
And then that Pi back there, what model Pi is that?
This is a Model 3 Raspberry Pi.
Okay, and you guys are running Pi KVM.
Pi KVM software that Maxim has built.
And you guys work with him actually to do a little bit of customization for your use case.
That's correct. He allowed us to work with him in an R&D fashion where we've got now a first-class citizen of a LDAP, as well as a NFS mounting capability for our NAS device.
Now, what about power? How do you actually turn the Mac on and off?
Yeah, so in our earlier versions of racking, power on and off was achieved through smart PDUs in the racks where we could, through a RESTful API to the PDU, turn on and off individual sockets, right? And so what we did is we would surface that capability in a button for a customer at the customer portal. And then when they push the button to turn on and off, toggle that, it would actually turn the socket eventually at the
So it was a
PDU.
hard reset.
It was a hard reset. But with this model, we don't do that at all. Instead, we have a servo that we leverage, and I can start to deconstruct this a little bit so we can get some more understanding of that. So this top tube is where the heat vents, right? We call this the shroud. And we have wires that go to the back of the Mini, right, through all the ports, right? And I'm just gonna disconnect those so we can get some more. This is the HDMI cable, Thunderbolt.
Okay. Both of the keyboard and the mouse simulations through that.
That's correct. Ethernet, and then of course power. Now that that's disconnected, what you'll see here is we've got nothing more than an off-the-shelf model car type of servo, you know, and this particular one we have used probably 10,000 times, continuously trying to make sure it has the ability to stand up to our customers' needs as it's flexing the power button. But this arm of the servo, through the software, the Pi KVM software, we can control it, and it allows us to press the power button, which is right here on the back of the Mini. And so we can either just depress it and turn off or turn on the Mini, but we can also put it into the mode where we can control the firmware and things of that nature.
Does the Pi remember the state of the Mac Mini?
The Pi will understand whether it's been reflected on this, and we also understand power to this, whether it's on or off.
Gotcha.
Consuming power.
Very cool. So how reliable is that? Because that's physical, which is a really cool solution to this. But when I think about the tolerances there, you know, there's physical tolerance. The button may have give as it gets used more frequently.
Yep.
You may have flex in the plastic. How reliable is it? How do you solve that problem of it actually depressing the button?
Yeah, it's a great question. So when we first built this component, so inside of this black housing is where we put the off-the-shelf component, which is the servo arm. But this housing went through many, many iterations. And what we ended up doing, there is this small little piece of plastic, right, that when this is in place, is a stabilizer on the aluminum housing of the Mini itself. And so prior to having that little piece of plastic, as the servo would flex into the power button, it would sort of warp itself a little bit over time. And so this, amazingly enough, this little piece of plastic has solved that problem altogether, and the stability is spot on every time now.
And so let's talk about the development cycle for this, because this is a game changer for how you guys innovate with new Macs coming out, because you have them to be reactive, because you don't, I mean, you have a good relationship with Apple, but you guys aren't privy to Macs before they come out.
We find out when the world finds out.
So, and you obviously, we have rumors from, you know, sites like Mac Rumors 9 to 5, you follow those closely to kind of prepare. But historically, you guys would work with a provider who would develop an entire solution. They would do design work with you, send you CNC samples.
That's right.
And the turnaround process for that is up to a year.
Yeah, it's a little bit, 12 to 15 months, depending on what we're doing in the complexity of that model of shelving.
So in that model, if Apple comes out with a different form factor, it's going to take you up to 15 months to have that solution.
That's right. We thought outside the box, and we made it very modular, right? You've got the shroud for the heat. You've got this component that allows the shroud to fit over it. And then there's also a handle that allows us to pick the whole unit up. It allows us to have the whole KVM system just come right off, right? And come right back on. And the beauty of it is, to the point you brought up, which is the M4 is about to come out, and there are rumors that the form factor of the Mini itself is going to change. That hasn't changed since 2012's model.
right? And we've been blessed because it hasn't. We haven't had to do a lot of stuff, right? But this is potentially going to force us. Well, we feel we're in a very advantaged space here because we can rapidly, because it's all modular, likely the only major thing that we're going to have to change is the housing that surrounds the Apple computer itself.
Sure. And this enables you to really have a true lights-off data center.
Yes. So the advent of the KVM system allows us to have complete control of the Apple compute, whether it's a Studio or a Mac, because we have both housings for studios as well as minis, and even down to the power button and how to get it into the firmware mode. So aside from physically being able to touch and remove a server, we can do anything we need to with the KVM system, because really at the end of the day, the KVM system is a management mechanism. Very similar to what HP has for the ILO, right, or many other enterprise class compute vendors have. Now we have it for Apple. And again, if something goes wrong with this hardware,
Completely modular.
I literally can take this off for a customer, right? Take this off for the customer and just replace it. And because of how we've architected this system coming online, as soon as we plug it into the network, it comes online.
Yeah.
And our back-end systems know about it, and they know what computer it's attached to. So, what is that? Maybe half a minute at most to take it out and put the new one on.
And they can still use the Mini.
Of course.
The Mini's online. They can get into it over screen sharing.
Absolutely.
Yep.
The only thing you're going to miss is the ability maybe to turn it on and off for that half a minute, right? The ability, at some point in the future, we're going to take the RESTful API of this and expose part of it to customers, right? Because there's value they can control things through. And so, but what's half a minute if something goes wrong?
And the other thing you can do over that USB cable is storage.
That's right.
So you guys can actually re-image this. So if I'm doing MDM profile testing and I want to try this on a different version, let's say I have 2 active versions of macOS, I can do it on one, re-image the machine, do it on the other.
That's right. And it goes beyond that. So not only can we do it for a customer, but eventually a customer is going to be able to do it themselves. And because we have storage opportunities in as part of our services for customers, they can store their golden images, right?
Yeah.
And they can do it themselves. And then on top of all that, we can experiment, right, for customers, and they can experiment. And so really, by doing this KVM system, we're opening up the real possibilities to our customers.
So let's go rack this guy up, shall we?
Yeah.
So here we have an apple pie. We just broke this down in the other video. In this case, what we're going to do is we're actually going to put it into the rack, right? And all we have to do is simply add this right here to the base, like we've talked about. And now we've got this in place. There is another component that would fit here to control the heat all the way across. And we've got PDUs in the back that we'd plug in.
Yep.
And of course, we've got Ethernet that would come from our topper racks through the back and into the KVM system, which would then power the Pi itself.
Okay.
All right, and it's that simple. So the future for MacStadium is taking everything you see around you and automating it, right? And this is part of that journey. Having the KVM system in place helps us with that journey. We've got some more work to do to write some code in the background. In the back end of our systems, we have of all this infrastructure, we have a system that knows about every device that's here and all the cables and all the power cables, the whole deal.
And you guys are using Cisco UCS clusters for your command and control, right?
We use Cisco UCS clusters, yep. And we also use a product called Autobot to be the source of truth for everything that's infrastructure, okay? It's our DSIM. And it allows us to then be able to, at any given moment, ask the data center, where do you have a Mini? Because the customer wants a Mini of a certain config that's available, right? And maybe that Mini is a bare metal just because some customer left it was bare metal. The new customer wants it to be Orka. Well, we can re-image that in 10 minutes or less and add it right into their Orka cluster. They don't know anything about it, but in 10 minutes or less, they get it handed over to them.
For those of you who don't know what Ork is, it is a pretty awesome tool that actually sits on top of macOS's own hypervisor, because macOS actually has a hypervisor that Apple built. Ork is a tool that sits on top of it that you guys developed and allows us to more easily utilize those VMs, and we can also use Kubernetes. So where historically the Windows developers, the Linux developers, you guys had a kind of a first-class experience. Apple developers, you kind of had to stick Mac Minis in your closet and hope they didn't overheat and do this yourself, and it wasn't the same experience. Now with Orka and you guys, that really is the same first-in-class experience for Apple developers and other use cases as well. And if you want to learn more about Orka, we have actually a link where you can download a free version of it and run it on your Mac. But you guys can, of course, do it through MacStadium. But watch our video. It's going to come out a little bit after this one, where we interview both the CEO and the CTO of MacStadium, and we get into the weeds of what Orka is, what you can do with it, as well as the future of Orka. Definitely worth your watch if you guys are interested in macOS virtualization. But it's not just Mac Minis that you guys have. You have Mac Studios.
That's right.
And Mac Pros.
Yep,
Let's check those out.
You bet. The Studio is about 2.5 times higher than a Mini, and so we can get 7 into a 6U height drawer.
Okay.
Right, and so the density here is 48. What you have here is all in the same piece of silicon. You have the CPU, the GPU, and the neural engine, right? So
at a much smaller cost than a dedicated. That's like the size of a GPU.
That's right.
Yeah.
And the RAM is up to 192 gig on this, so that's just crazy.
Awesome.
Yep.
So a lot of you guys are probably wondering, why aren't they just using the rack mount Mac Pros? I mean, these things are rack mountable in a 5U form factor. You can get a lot of Apple compute in them. So these really haven't been a great success for you guys, though.
That's right. So the reason they're not successful for our current customer set is that although there's a ton of power in it, at the end of the day, Mac OS only allows you 2 virtual machines per system. So if you're a developer, you just can't use all of its goodness.
Sure.
Right? So these are really leveraged, frankly, by Hollywood studio type of customers that need amazing capabilities for video and audio editing, right? And that's who uses these from us.
And that's especially true in the use case of VDI.
Absolutely.
Yeah.
Same thing. Orka or VDI has the same problem. You can only get so much stuff on it.
So this is the core of your guys' network infrastructure right here.
That is. So this is a Nexus 9508 series with 100 gig optics.
Woo.
It is one of 4 in this data center,
Okay.
which means we have 400 gig east to west traffic in this data center.
So this is more of a spine.
This is the
Spine leaf
spine.
architecture. Okay.
So MacStadium about 7 years ago switched from a campus network to a spine leaf network.
Okay.
And we're one of the largest spine leaf networks in the world.
And that's going to set you up very well for AI workloads, where you're going to have much more east and west traffic than your north and south.
Absolutely. Yep. The great thing about this is I can literally rip this apart right now and no customer will know, because I've got 3 other spines. Every top of rack switch goes to each spine, independent, right? And so no customer will ever feel it when one of these goes down or 3 out of the 4 go down.
That's awesome.
Yep.
And with this, you guys have actually general storage as well, for whether folks are using something like the Mac Pros with iSCSI, they're actually loading everything off of the SAN.
Hyper-converged networking, right, with storage and everything. So a number of years ago, we invested in pure storage. Our customers wanted low latency for their iSCSI capability for VMware, right? And so we invested in flash arrays from Pure. Each one of these is a flash array. These are F70s. They have 106 terabytes each. Very low latency, somewhere, if I recall, somewhere around 3 to 5 milliseconds.
Wow.
So really quick. It's all NVMe storage.
That's expensive.
Very expensive, but again, our customers demanded really quick response times. When we went to Orka, we didn't opt for iSCSI. Instead, we went for NFS capability. So we went to the Flash Blade, which is a highly parallelized NVMe capability. The latency is a little larger, but it's NFS instead of iSCSI.
And for those customers, are you guys having the OS local? Or is the OS loaded off? Because we have a
No, the OS is local.
It's local now,
Yeah.
so you're using this for secondary storage.
That's correct.
Okay.
Yeah, 100%.
Super cool.
And our next generation of storage, these are still very, very useful for us, but our next generation storage is more of a software-defined storage appliance, right? Where we're using Supermicro and off-the-shelf NVMe drives with a layer of software, right? So that reduces our cost more in line with like an S3 you might get from Amazon.
Gotcha. Are you guys looking at a true NAS at all to reduce that storage
That would be
cost?
a true NAS capability. Yeah,
Oh,
yeah.
that's really cool.
Yep.
So another thing I want to look at is how you guys manage all of this infrastructure, because you have how many, hundreds and hundreds of devices.
We got over 25,000 devices that are just Apple devices.
Okay, that's insane. But
Yeah.
so way higher than I was saying. But you guys have to manage all these devices.
Yep.
And inventory them.
Yep.
How do you do that?
So we do that through a software product that we've recently adopted, the Nautobot capability. It's from a company called Network to Code, and it's our DSIM and IPAM, right? And so literally everything in this data center, racks, shelves, storage devices, minis, studios, UCS, everything is in that system, and it allows even the Pi KVMs we talked about, right? The KVM systems. It allows us to know where everything is and know who's attached to what's upstream and downstream. So if there's an issue, we immediately know what's upstream that could be causing it and what's past it downstream that could be affected by it.
Gotcha. And that's running on all UCS clusters?
That is all running on UCS.
Let's take a look at that.
All right.
So this is a Cisco UCS cluster.
Yep.
And for those of you who don't know, Cisco makes some of the best, most capable physical servers. Now they're expensive. They're about twice the price of an equivalent Dell EMC or HP Enterprise.
Yep.
But for something like this, where they're so critical, I mean, you see how you guys have a few other places in the DC where you have UCS.
Yep.
But you don't have a lot of this.
Correct. So this capability for us is critical to keep up and running, right? And so much of what you see around us depends on it that we cannot afford for this to go down. And so UCS was the easy choice for us. We were already a Cisco shop for our networking, and this gave us insight into our network more than we had before because of it. And it also is so redundant. And on top of all that, it deals with images. So if you pull one of these devices out, it automatically transfers the image somewhere else and it's up and running and nobody knows about it, right? That's how fail-safe these are.
Yeah, Cisco UCS is awesome. You pay for it, but it's awesome. And when we ever go to Mars and we need to have infrastructure on Mars or on the starships going to Mars, it's going to be a Cisco UCS cluster, I think.
Absolutely.
Awesome. So Paul, these are empty racks.
They are.
This is room for expansion.
This is our latest annex of space. We have approximately 132 additional racks that we can put in here. Right, what you're seeing now is about 126 of those 132.
Okay. And these look like they're mostly standard racks, right?
These are all standard racks. The only, if you want non-standard pieces, they're taller than the traditional 42 or 48U. These are all 52U racks. It gives us the density we need.
Sure. Height is a factor you can take advantage of.
Height is a factor.
And they're Rack Solutions racks?
They happen to be Rack Solution racks, but they could be any vendor that's a standard footprint rack.
Well, Rack Solutions makes a good product.
They do.
So.
We use them exclusively.
Awesome. Well, Paul, it's been a pleasure coming out here and seeing what you guys are doing and the innovations that you guys are bringing to the Apple world for Mac and for AI and for so many other things coming down the pike. So it's been an absolute pleasure.
Thanks for coming by. I really appreciate it.
Thanks for having us.